All right, so today we are going to start a brand new chapter, and this whole chapter is going to be something called conic sections. And so before we even get into our notes, I kind of want to go over what conic sections are. So today on your bell ringer, I asked you guys to sketch a picture of a cone. Okay, and if you didn't really remember how to do that, or you were a little bit unsure about how you were doing that, you got to kind of think back to your geometry days, because that is when you would have talked about three-dimensional shapes like prisms, cylinders, pyramids, cones, spheres. You would have talked about all of those shapes and how to find surface area of them, how to find volume of them. And so we're going to kind of extend on that here today in Algebra 3, and we're going to be talking about how to find conic sections throughout this whole chapter. Before we get into the first conic section, just want to show you what I'm talking about, give you like a visual so you kind of have an idea of what these conic sections are. So first of all, conic sections can look like any of these examples that I have here. Now, you've already, in this class, we've talked about how to make an equation of a circle before. And so what a conic section does is it's a double-sided cone. So a cone would just be like the bottom half here, but when they have two of them stacked and like the apex points of those cones, kind of where they all come up and meet at that point, when those are connected and then it kind of reflects the cone on the other side, this is going to allow us to create conic sections when we start to slice this cone in different directions. So they're showing you on this first one here that the conic section is created with a circle when you have this plane kind of come in almost like horizontally to it and just allows it to kind of cut like that. So that would create a circle. And like I said, in the past, we've already done conic sections of circles before. Like we've been able to graph a circle. Okay, but what we're going to talk about in this chapter is the ellipse, the hyperbola, and the parabola. The ellipse is a different conic section on the same picture. It's just your plane that you're using to kind of do the slice doesn't necessarily go in horizontally. It kind of starts to go in more at an angle. The hyperbola happens when you kind of make a vertical slice through your double conic section. And so it's actually going to have a portion on the top and a portion on the bottom that are still reflections of each other. And then our parabola is just a different angle of that slice happening. And so it's going to create that U shape that we've seen before when we dealt with our quadratics. Another picture kind of illustrating these different conic sections that I have is this one here. So kind of all on a single cone. So they're not showing you the double cone anymore, but you can see your circle, the ellipse, the parabola, and the hyperbola, kind of how all of those are being split at different angles of our cone. And we're able to kind of see the shapes that are being formed here. I also have this website here. I'm going to just kind of pull this up and I'm just going to hit this button here and it's going to start making this blue plane move and it's going to show you all those different conic sections. So it's going to start with a circle there, and then as it goes, it's starting to make that ellipse. Then it's switching to a parabola, and then this last one is where that hyperbola shows up. And so it's going to kind of just go back and forth. I'm going to let it run here for a minute just so you can kind of see those. But we've already done circles. Today we're going to talk about how you do the ellipse, which is kind of like a circle, but it's more of an oval, okay, like that shape right there. And then eventually we'll talk about the parabola again, and then this last one, which is the hyperbola. But this kind of gives you an idea of where these things come from. They're not just these random shapes that I've decided that we're going to talk about or that are just coming out of nowhere. These are shapes that are formed when we start to slice a cone in different angles. And you can even see up here like the rotation of the angle of that plane is changing. And so it's allowing those different shapes to show up. All right, so we are going to get into the ellipse today and actually how to graph an ellipse. We're going to talk mainly today about how we can graph an ellipse that are centered at the origin, so 0, 0. And in the future, we'll talk about how you graph an ellipse when it's centered not at the origin. We'll also talk about how to write equations of ellipses in this section so that we can kind of be given information about the ellipse and then use it to create our equation. You kind of saw on those pictures and kind of that illustration that I gave you, like what an ellipse is. But an ellipse is like an oval-like shape. And what truly makes an ellipse is that it's the set of points that are all going to be a specific distance away from these two fixed points, which they're saying are the F1 and F2. Those two fixed points are called the foci, which is plural of focus. So we could say they're the focus points, or somebody might say these are your foci points. And then the midpoint of the segment connecting those foci and then also going out to the edges of the ellipse is going to be your center. When you have an ellipse, you'll also have these points that are kind of on either side of your focus points, like here and here. These are going to be your vertices. So this would be a vertex, and this would be a vertex here as well. You're going to have two of those, so that's why we have vertices on these. And then you will have points that we find that would be about like here and here. We don't really have like a name for those points, but those are going to be on something called our minor axis. So down below it kind of goes into like what makes something a major axis versus a minor axis. The major axis is going to be the line that connects the focus points and the vertices all together, and it goes through the center. And the major axis is going to kind of tell you how your ellipse is going to be positioned on your graph. So whether it should be kind of laying on its side or if it should be standing up tall, like up and down. The minor axis is going to be perpendicular to that, and it's going to give you kind of those other boundary points to kind of give you an idea of where your ellipse should be at. So gives you an idea of what the picture would look like. You can see down here on these pictures, the one over on the left side, this would be considered the major axis to be vertical because it's standing upright. It's along the y-axis. That's why we would say it's a major axis vertical. The one on the right here is a major axis horizontal. So instead of it going more up and down, it goes farther left and right. We're going to be practicing today how to find and differentiate whether it's a major axis vertical or horizontal. We're going to talk about how you find your vertex points, how you find your focus points, how you find those points on the minor axis, so that then you can start graphing your ellipses. If you go to the next page here, this next kind of chunk really gets into some of the details that we're going to be looking for today when we do our ellipses. All of the ones that we're going to start with today are going to be centered at the origin. Remember, that's the point 0, 0. So it's going to be centered on our graph. We have to know what a standard form of ellipse looks like, and they're giving you a couple of examples down below. Both of these equations have a lot of things in common. They both have an x squared and a y squared with a plus sign in the middle of them. There's fractions involved, and then it says equals 1. On the bottom of the fractions, those denominators, that's when we see a little bit of a difference. So on the left-hand side, you can see how the a squared is underneath the x. And on the right-hand side, you can see how the a squared is underneath the y. Okay, there's a reason why it's switching. The a squared and the b squared numbers are going to be filled in with some numerical value for us. And when we look at those numbers, all that we really want to look at and be able to differentiate is which one's bigger. Because the bigger one is going to tell you whether you have a major axis vertical or a major axis horizontal. When the larger of the two numbers, so the a squared, is underneath the x, this means that you're going to have a major horizontal. That just means when you go to graph your ellipse, it's going to go long side on the x-axis. It also shows you down here, like the A and the C points, those are going to be your vertex and your focus points. The A points are going to be your vertex points. The C's are going to be the focus points. Those are going to be along the x-axis. And so the numbers that we fill in on our coordinates are going to go first, and then they're going to be, the second number is going to always be a 0 for the y. The B terms here, those are going to come from the y underneath that, so that's why they're going on the y-axis. And those are just going to be along the minor axis for us, and that's going to help us kind of just get an idea of where the rest of the ellipse is at. On the other side of things, you can see how it shifts because the a squared now is underneath the y squared value. So this side means that it would be a major vertical graph. Okay, it'd be going up or down. Again, this is going to just shift. My A's now are still my vertices, but those are going to be going up and down. And the C's are my foci, and so those, again, are going up and down instead of what they did on the first example. And then your B points are now along the x-axis because that's going to be your minor axis. Now, when you look at all of these points, you saw a lot of a's and b's and c's, and we can see where a and b comes from up in our equation because we see an a squared and a b squared, but where does the c squared come from? Like, where does the c show up? How do we use that point to graph our foci points? So down below here, it shows you how you could find your c using this equation. C squared can be found by taking a squared minus b squared. Now, don't get this confused with Pythagorean theorem. Okay, Pythagorean theorem, you would have done that in geometry too, is your a squared plus b squared equals c squared. That works on those right triangles. We're switching it a little bit here for the ellipse. This time, instead of adding a and b, we're actually going to be subtracting them. And that's going to help us find our c squared. You'll also notice over here they are giving you an equation that you could use if you needed to find b squared. And I just want to kind of highlight that because that's going to come up a little bit later in our notes when we're writing out equations of lengths. Okay? So now that I've kind of gone over some of the details behind these, I'm going to now let us do an example here together. So what I'm going to do is kind of talk through this problem that we see on our page here. We're going to go through the steps so you can kind of see where they're getting all these letters from and then how it applies to the graph. So step one is to make sure that your equation is written in standard form, and that means that it needs to be set equal to 1. If we look down at the example I have, it says 16x squared plus 9y squared equals 144. Right now, it is not in standard form. This equation does not say that it's equal to 1, so we need to start there first. To get it to equal 1, I need to get rid of that 144. And so the best way to do that is just to divide everything by that 144. So you can see how they're doing that down here on this step. They're taking all the terms in the problem divided by 144. Now over on the far right side, when you take 144 divided by 144, you're just going to get 1. But over here on the left, we can't take 16 or 9 and divide by 144 nicely. But we can try to reduce them and still have those fractions involved. So what they did here is they looked to see how could 16 over 144 reduce, and then how could 9 over 144 reduce. If you're not sure, you can always type it into your calculator. Just put in 16 over 144 and write it as a fraction. For this one, it should come out to be 1 over 9, which is why they wrote it as x squared over 9. And then for the y squared, something similar happens. If 16 could go into 144 9 times, then 9 should be able to go into 144 16 times, okay? So that's where these bottom numbers come from. The 9 and the 16 come from me reducing those fractions. Now it's written in standard form, so we're working with this as our equation. X squared over 9 plus y squared over 16 equals 1. This next chunk here, steps 2 through, I would say 5, like steps 2 and 3 go together, and 4 and 5 go together. They are to establish what is your A and your B, and this is also going to help us understand whether we have a major vertical or a major horizontal. Now you can already just see from the graph that it is a longer going up and down ellipse than it is going left or right. So this would mean that it's a major vertical, but let's talk about why. So if you look down at your equation here, the 9 and the 16, those denominators, we need to worry about which one's bigger. 16 is bigger than 9, and since 16 is underneath the y, this means we're dealing with a major vertical ellipse. If it was underneath the x, it would be a major horizontal instead. But since the bigger number is underneath y, it's major vertical. So to find my a and my b, I need to just look at those bottom numbers. Now, the 16 is going to be my a squared, and the 9 is going to be my b squared. A squared is always the larger of the two, and b is always the smaller. To find regular a and regular b, then you have to square root those numbers. Now, for the purposes of right now, we're probably going to see some perfect squares show up just to try to make it a little bit easier on you guys as you're getting used to graphing ellipses. There will be times, though, when we deal with square roots even like when we're trying to find our c, that we may not get perfect numbers that we put into our square root sign. Okay, so just keep that in mind, that we might start to see some that have to change a little bit. When I square root 16 to get my a, that's a 4. But remember, technically when we square root something, it's always plus or minus 4. And so they're writing those equations, or those coordinates I should say, out as 0, 4 and 0, negative 4. Now why the 4s come second is because this is a major vertical graph, which means that your vertice points are going to be on the y-axis. A is helping you find your vertices. So when it's on the major y-axis here, it has to be those numbers filled in for the y-coordinate. And the zeros are going to be x's. So 0, 4, and 0, negative 4, you can see these on your graph here. That's this point here and this point here. These are going to be those vertex points. Okay. The B is going to be along your minor axis. So that's going to be on this one along the X, because it's a minor going that way. When we square root the 9, that's how we got 3. But again, it's plus or minus 3. This time when they write out these coordinates, 3's are coming first because it's along the x-axis. And so you can see those points are here and here. And again, we don't really have names for those. Sometimes you might hear people say they're called like the co-vertices. So I think maybe last year you guys did a little bit of this in Algebra 2. We would sometimes call these the co-vertices because they're along the minor axis instead. You could call that co-vertices if you wanted to, or label them CV if you'd like to. I may not call them anything for right now. I just kind of need them there so I kind of know how do I draw my ellipse in. Because with those 4 points, I should be able to kind of draw in my boundary of my ellipse. Okay? But the other thing that I do need to put on my ellipse is my focus points, my foci. So we just took care of steps 2 through 5 by finding my A and my B. The last thing I need to find is the focus points, and that's being able to find your C. And remember, we talked about that equation up above, that to find C, you would do A squared minus B squared, and that's what they're showing you here. A squared was 16, B squared was 9, so 16 minus 9 is 7. Now we're going to want to square root the 7 so that when we actually graph, we can maybe think about these as numbers, because to think about the square root of 7 is maybe not the easiest thing to think of when we're graphing. Again, my foci points are going to be along the same axis that my vertices were on. So these 2 points are going to be written the same as my vertice points were written, where they're going to come second because they're reflecting on the y-axis. But the square root of 7 comes out to be about 2.6. So another way you could think of this is it's 0, 2.6, 0, negative 2.6. And that's going to be these points here. I'm going to put an F here and an F here for those foci. So those are your focus points. Something to keep in mind when you're graphing an ellipse, the focus points should always be on the same line as your vertices, but they should always come before the vertices. So when you start at your center and you work your way along that axis, the focus point should come first and then the vertices should follow it. That lets you know that you're putting them in the right spot and that you did your calculations correctly. Okay? So that gives you an idea of how we're going to graph these types of ellipses here. Now, I did mention that you did do this last year in Algebra 2. So this may look or seem like you've done this before or maybe feel a little familiar. If it doesn't, that's okay, because I just went through how you're going to do that. But you did do this in the past, but it's been about a year since you would have talked about that. So it's okay if things are a little bit fuzzy and you just don't remember doing it. I want you guys to turn your page, and I want to see what you can do with this one on your own. So I'm going to just kind of pause here for a minute, and I'm going to give you a couple of minutes to go ahead and just try to work through this at your own pace. I will probably give you about 2 to 3 minutes here, and then I'm going to start talking through what I would do. Okay, I'm going to start working through this here. First thing that you should have done is try to rewrite it in standard form. And to do that, we need to get rid of this 100. So we're going to divide everything by 100. 4 over 100 can reduce to 1 over 25. So this would become x squared over 25. And then this would be y squared over 4 equals 1. So this is the form I want to use. Now I can start my process of figuring out my vertices, my foci, what's my major and my minor axis. Now the bottom numbers, 25 and 4, the larger of the two is always your a squared. So this time your a squared is 25 and your b squared would be 4. Since the a squared is underneath the x squared, this would mean that it's going to be a major horizontal. To find my vertices, I need to square root 25 because that's going to be my a term, which is a 5. So a is going to be 5 plus or minus 5. And since it's a major horizontal, that would mean that your points would be written as 5, 0, negative 5, 0. The 5s come first because if it's a major horizontal, that means that it's going to be along your x-axis. So I'm going to go ahead and graph those points. 5, 0, that's a vertice, and negative 5, 0, that's a vertice. Okay? Then we're going to go to finding my b, because these are going to be for my minor axis. So I'll just write minor axis. This would also be those co-vertice points I kind of mentioned a little bit ago. So the square root of 4 would be 2. So your b is going to be plus or minus 2. And these are going to be on your y-axis. So 0, 2, and 0, negative 2. So you're going to go up and down 2 for those points. At this point in time, you could go ahead and connect and make the outline of your ellipse. So you get an idea of what it looks like. The last thing, though, that I'm going to be looking for on your graphs is your focus points. So we're not totally finished yet. To do your focus points, we need to figure out what the c squared is. And to find c squared, you do a squared minus b squared for an ellipse. So you're going to do 25 minus 4, which would be 21. And we're going to have to square root that. And again, we're going to want an actual number that we can think of when we're trying to graph this. I don't want to think about trying to graph square root of 21 because I don't know what that is exactly. So if I type that in and I round it, I get about 4.6. Now remember, your focus points are going to go along with your vertices. So your vertices were written with the number first. So when we write these out as coordinates, it would be 4.60 and negative 4.60. And then you're going to graph those, and you're just going to do your best on where you think they are. And I'm going to put a little F by them to label those as my focus points. But that is the gist of graphing an ellipse when it's centered at the origin. A little bit later in this section, we'll talk about how you handle it if it's not centered at the origin. It's really not too different than what we just did. We're going to kind of handle them the same way. We're going to still find our A, B, and C and all those things the same way there. But we will just have to make one minor little tweak at the very end of our problem. Okay? Before we get into that, though, the next thing I want to talk about is instead of graphing an ellipse, I want to be able to write the equation of an ellipse. So they might give me some information about my ellipse here, and then they want me to create the equation that it came from. So we're going to do an example together. They are going to maybe tell you where it's centered at. Since we're still just dealing with the origin, this is still just going to be centered at the origin point here. They're also giving me my foci points and my vertices. Notice how they're both written the same way. And this is going to be able to tell me kind of a lot. This is going to help me find a lot of the things that I need for my graph. First, it's going to tell me whether it's a major axis vertical or horizontal. Based on how these coordinates are written, we should know that. Since the numbers 2 and -2, 3 and -3 come first in the x coordinate spot, that means that this is a major horizontal graph. Because these numbers are written first. Okay, that's how I know that. If the zeros were in the x coordinates and then the numbers were in the y, then it would switch my major to a vertical. That means when I go to graph this, when I go to write my equation, the a squared should go underneath my x squared in my equation. So that's what they have this down here. Notice how the a squared is underneath your x squared, and then the b squared is underneath your y. Okay, so we need to figure out what is a squared, what is b squared. Now, a squared comes from your vertices. So because the number that they put in is 3 and -3, that means that your a is a 3. So a squared would be 3 squared, which is 9. So 9 is going to go underneath your x squared, and we can see that happening down here. Okay, so that's where they got that 9 from. Now, the foci points, that's not my b, but that's actually c. And so the c here is going to be a 2, which means your c squared would be 4. Now, a little bit ago, when we were kind of talking about the details of how you get to the graph of an ellipse, I went over that sometimes you'll have to find C, but I also had highlighted that sometimes you'll have to find your B. Okay, I need to find B for this one because they don't give it to me. They give me my A and they give me my C because those come from my vertices and my focus points. So to find B, I need to use this equation. A squared minus C squared. We said that A squared was 9. We said c squared was 4, so 9 minus 4 is 5. So this 5 here needs to go underneath the y, which it does. That's how they get to this equation down here. X squared is over the 9 because that's my a squared, plus y squared is over 5 because that's my b squared, and it's going to equal 1. All right, I'm going to give you a minute to go ahead and try one by yourself. Okay, I'm going to start working through this here. So the foci points and the vertices are now written where the number is being put into the y coordinate spot. So this means that we are dealing with a major vertical graph this time, which means when I write it, my x squared should be over the b squared, and y squared should get the a squared this time. Okay, I gathered all of that by just looking at how those coordinates are written. They all start out zeros, and the numbers are being put into the y's, so that's what tells me what major axis I'm working with. Your foci points are going to tell you your c value. So c is going to be equal to a 2, which means c squared should be a 4. Your vertices are going to give you your a value. So a is a 4, which means a squared should be 16. So I'm going to go ahead and start thinking about my equation here. I know that underneath the y squared, I should write 16. okay, because that's going to be my a squared value, and I just found that up here. Now I need to find my b, because that needs to go underneath the x squared. So remember the equation we talked about a little bit ago? To find b squared is to take your a squared minus c squared. So 16 minus 4 would be 12. And that's going to be our b squared, and that's what should go underneath the x. So this would be your equation. X squared over 12 plus y squared over 16 equals 1. All right, I am going to stop here for today. Tomorrow when we pick up, we're going to talk about how you handle the ellipses when they're not centered at the origin, and how to write an equation of an ellipse that's when it's not centered at the origin as well. So I am going to hand out the homework because you should be able to get started on it. The first couple of problems on your assignment are all dealing with the ones where you should be able to have them be centered at the origin. So you should be able to do, just looking at it here, probably the first page at least, and then maybe when we start getting into some of those later problems, like even when you get to your homework, I would say you should be able to do the first 9 problems. You should be able to get done with just what we've talked about today, okay? And then you might need to wait to do the rest until after we finish up notes tomorrow.